Hello everyone! In this video we're going to be going through LeetCode problem 145, which is binary tree post-order traversal. So this problem states, given the root of a binary tree, return the post-order traversal of its nodes' values. So if you remember, post-order traversal starts with the left leaf node, and moves left to right up the tree, and then the root node is the last node, and is post-order traversal. So if you look at the examples here, the output here is 3, 2, 1. You start at the left, there isn't a right, go up here, 2, and then 1. Example 2, empty array passes back an empty array. Example 3, we just have the root node of 1, so the output will just be 1. And then example 4, 1 and 2, starting with the left leaf node will be 2, and then the root value of 1. And same thing here. The right leaf node, and then the root. And once again, they're asking us to not do it recursively. All right. So this is very similar to the pre-order traversal. I just did this video, or that video. So we're going to pass in the tree node root, and we're going to pass back a list of integers in post-order order. So the first thing we'll do is create a linked list of tree nodes. I'll call it stack, and I'll instantiate it. Now we need to pass back a linked list of integers, or a list of integers. So I'll create that and call it output and instantiate it. So if the root equals null, we're just going to return the output, which in this case will be 0. All right, so now we're going to add the root to the stack. And then while the stack is not empty, so we're going to create a tree node, and this time we're just going to do a peek, because the root node is the last node to in the list, so we don't want to pull that off the stack. So it's, if you think of a stack of plates, it's the plate on the bottom. So we're going to leave it there. So if it happens to be the only node, so if the node right is null and the node left is null, then we're going to pop it off, and then we'll assign the node value to the output. Okay, so I couldn't fit all this code on one slide, so this is still within the while statement. Okay, now assuming that we don't need to pop anything off yet, we're going to see if the node right is not equal to null. And if that is the case, then we're going to push the node right onto the stack. And then the node right, we got to make that null because we don't want to push it on the stack twice. And then we're going to do the left node. So we always do right before left, because when we're stacking plates, we want the left one to be the last one on the stack, because we're traversing left to right. So node.left is not equal to null. We're going to push the node.left onto the stack, and then assign that left node equal null. And then that is it. We'll return the output and close the method. So I think the debugger should help explain this a little better. All right, so I used that first example of 1, 2, 3 actually. So we need to return 3, 2, 1. So the first thing we're going to do is instantiate the stack and the output. Now if root is not equal null, so root is 1, which has a right value of 2, and then the 2 has a left value of 3. So that is not null, so we're going to add the root. Well, stack is not empty, we're just going to peek. And that will just show the 1. So if node right equals false, which it isn't, and you can see here it just checks the first one because this is an AND condition, so if one of them is false, then it doesn't matter what the second part of the condition is. Okay, so it skips this loop. So if node.right is not equal to null, that is true. So now we're going to push the node right onto the stack, which is the 2. And then we're going to assign that node right equal to 0. So now if node left is not equal to false, which it is in this case, so now we're going to peek here, and you notice that we're dealing with the 2 now. And the 2 has a left but not a right. So the right is null, however, the left is not null. So we're going to skip that, that loop. The right is false, and the left now is true. So we're going to push that node onto the stack and assign the left equal to 0. Okay, so now we're going to peek, and now we're dealing with 3. Well, now everything is null because we've gone through all the nodes. So now we're going to start popping stuff off the stack. And the first thing we pop off is the 1. So we're going to add that to the output. So the output should be, I'm sorry, the first thing we're going to pop off is the 3 because it's on the top. That's the left node that we just added. Okay, so we'll skip these 2 loops. Now we're going to go back and peek, and now we should see the 2. Why am I struggling here? Yeah, the 2. Okay, so now we're dealing with the 2. So we're going to pop that off the stack, and we're going to add that to the output. So now all we have left is the 1. And we're going to peek at that, and we're still dealing with nulls on left and right. So we're going to pop off the 1 and add that to the output. Those are both false, and now stack is empty. And so we're going to return the output, which is 3, 2, 1. And that is the answer that we're looking for. All right, let's run this through LeetCode. Let's see what we get. Hey, accepted. Submit it. Okay, this is faster than 20% and uses a lot of memory. I'll try it one more time. Probably not going to get anything. Oh my gosh, 100%. And less than 74% memory. So this is, that's pretty good actually for this code, because normally you do it using recursion, and that should be a lot faster. But anyway, let's go back and do the space and time complexity. Okay, so time complexity is O of n. As we increase the binary tree and all the nodes, it's going to increase the execution time through that while loop. And then space complexity is the same thing. As we increase the binary tree, we're going to need more space for that. And that is it. So once again, thank you for watching. Let me know if you have questions, and we'll see you next time.